This video is going to go over the Unit 11 Angles Review assignment. Feel free to jump through to any problems that you have questions on. Let's go ahead and get started. Question 1 asks us to find the measure of each angle, given that angle 3 is 57. So these are the angles I need to find down here, but let's go ahead and just find them all and then fill those in. So I'm going to start by labeling angle 3 as 57. Now remember, when I have two parallel lines cut by a transversal, if I cut these two parallel lines apart, like if I were to snip the line right there, and I were to pick up this little intersection and slide it down the line to here, you would see that they perfectly line up. So angle 3 will line up exactly on angle 7. So angle 7 therefore has to be also 57 degrees. We also know that because I have two lines crossing at this intersection, that my angle that shares the same vertex are called vertical angles and are the same. If I were to fold on this little line right here, angle 3 would line up on angle 2. So angle 2 is also 57, and if I slid that back down, 6 would also be 57. So that would be corresponding between 2 and 6. Now, as I look at that diagram, those are the only angles that look to be that small and that 57 degrees. The other 4 angles are large. Remember how to get those is to recognize that I have a linear pair. So for example, if I were to draw a straight line, and here's a straight line, if I were to start facing to the left and I were to go and turn to here and be facing this way, that's a 180 degree turn. So to get angle 4, I'm going to, in my calculator, type in 180 minus 57. So 180 minus 57 gives me a grand total of 123. So this angle 4 is 123, and if I were to slide this intersection down, 4 is corresponding to 8, so that's also 123. And 1 and 4 are vertical angles, and 5 and 8 are vertical angles. And again, you'll notice that I've got this alternation, 57, 123, 57, 123, 57, 123, 57, 123, and they're only those two sizes of angles. So let's go through and answer. Angle 2 is 57, angle 4 is 123, angle 7 is also 57, and angle 6, 57. Great. Let's move on. So state the angle relationships for the following pairs. So that's what I was saying with the vertical angles and the corresponding angles. Here is our list. So we have vertical angles, corresponding angles, alternate interior angles, and alternate exterior. And I'm gonna eliminate, we talked about same side, I'm gonna eliminate those. I just want to focus on these 4 right here. So as I look at this diagram, I'm going to be looking at in this box to see what angles I'm comparing. So 1 and 4, here's 1, here's 4. Now remember, interior is between the parallel lines and exterior is outside. So 1 is on the exterior and 4 is on the interior, so neither of these alternate interior-exterior rules are going to work, because if it was alternate interior, they both have to be on the interior, and if it's alternate exterior, then they both must be on the exterior. So I'm choosing between vertical and corresponding. Remember, vertical, they share a vertex. So vertical, they share that vertex. So 1 and 4 are vertical angles. All right, let's choose a different color. 6 and 3. Notice they don't share a vertex. Corresponding would be if I were to slide my intersections and they were lined up on top of each other, and they're not going to. 3 lines up with 7 and 6 lines up with 2. So no, not corresponding. But I do notice that they're both on the interior, and they're on opposite sides of that line. So I'm going to say alternate interior. 1 and 8, different color. Here's 1, here's 8. And this time I notice they still don't share a vertex. They're not in the same position, but they're both on the exterior, and they're on opposite sides of this single line. So this is alternate exterior. And 8 and 4, so let's just underline 8 and 4. One's on the exterior, one's on the interior, so these two options are out, and they don't share the same vertex. But remember, corresponding is when if I have two intersections, I cut it in half and I slide it down, pick one up and stack it on top of the other, they would line up. And indeed, 8 lines up with 4. So corresponding. And those are how I name my angle relationships. Let's continue. So use angle properties to solve for x. So this time I don't have parallel lines, but notice I do have two angles that share a vertex. So these are vertical angles. And vertical angles are equal to each other. If I were to cut my line right here and fold it, okay, this would line up on 3x would line up with the 2x plus 16. So because they are equal, I'm just going to write an equation. 3x equals 2x plus 16. Draw my line down my equal sign. Okay, I've got variables on both sides. This is my bigger variable side, so I'm going to make that my variable side. Minus anything that's not just a plain old number, so minus 2x. And I get x is equal to 16. And that's just my final answer. I don't have any other steps because I just have an x. Solve for t. Now on this problem, you might say to yourself, oh, that looks very similar to the last one. I've got these two lines crossing. But I want you to just take a second and ask yourself, do those two angles, this angle and this angle, do they look the same size? The answer is no. The other question is, do they share just the vertex? Now they also share this side. So these are not a vertical angle and these are not the same size. So please do not run into the problem of writing this equation, because that's going to give us the wrong answer. I'm going to use my knowledge that lines, straight lines, if I were to start here and swing all the way around to here, that's 180 degrees. So if I have a total of 180 degrees, imagine this is a pizza slice. I've got half a pizza right here, so 180 degrees of a pizza. Hey, what two piece of pizzas make up my 180? 20t plus 5 makes up one slice, plus 15t makes up my second slice. And I'm going to go ahead and combine. 20 plus 15 is 35t, plus 5 is equal to 180. Continue to bring down my equal sign and the 180. And then to solve for t, I'm going to get rid of whatever's furthest from it first. So I'm going to minus 5. So I'm going to get 175 equals 35t. Now that looks like a hard division problem in my head, so 35, sorry. So I'm going to use my calculator. 175 divided by 35 is 5. So t equals 5. And that's all it asks me to do. Solve for the missing angle. Now here I've got a triangle. Remember, the fact about triangles is that if I were to take all of the angles on the inside, the interior is a total of 180 degrees. Just like a straight line is a total of 180 degrees, a triangle is a total of 180 degrees. So how do I find that missing one? Okay, well, add the two together that I know. 57 plus 61, 58 plus 61 is 119. Find my remaining. I'm going to take 180 and minus 119, which gives me a grand total of 61. So x is 61. And that's it. Now, what do I do if I have a problem? If I've got all the interior angles of a triangle, but there's expressions involved, some variables involved in my problem. Well, I'm going to do the same thing. I'm going to say note to self, all of the inside angles should total to 180. So I'm going to write 180 equals, now all of these pieces of pizza, my angles. So 2x plus 100 plus x plus 5. Notice there's 2x, there's 100, and there's x plus 5 equals my 180. So let's go ahead and simplify. Draw down my equal sign line, and I have, it's kind of messy, let's clean it up, 180 equals, and I'm combining the x's, 3x, and then 105 is a total of 105. Solving for x, I'm going to minus 105 because that's the furthest thing away from x. 180 minus 105. 180 minus 105 is 75. 75 is equal to 3x. And when I divide by 75 divided by 3 is 25. 3/4 go into 75 cents. That's how I did that in my head. So x is equal to 25. So I've got a similar one. You can take a second and try this one on your own if you haven't already. I've got all the inside angles of a triangle. So again, I'm going to write 180 equals, and then I'm going to add them all together. So x plus 51 plus 2x. Combine my like terms. 180 equals 3x plus 51 minus 51. Calculator, 180 minus 51 is 129 equals 3x. Divide that by 3. 129 divided by 3 is 43. So in this case, x is equal to 43, and I'm done. Great, we're about halfway there, so let's keep going. So find the measure of the indicated exterior angle marked with a question mark. So I want to figure out how big this angle is. Now, if you're thinking, oh, it's a triangle, 180, and all I have to do is subtract. Well, you're close. That's how I find the inside of that angle. Let's go ahead and try that. So 35 plus 95 is 130. Let's write that down. So 130. And to get this last remaining inside angle, not the outside one, that's what I want for my answer, the outside, but the inside, I'm going to take 180 minus 130, which gives us a grand total of 50. Now, how do I get that outside angle? And you might be saying, I don't know. But remind yourself that this is a straight line right here. So remember, I've got half of a pizza pie. So that's 180 degrees. And my two pizza pies are made up of 50 and question mark. So 180 equals 50 plus my question mark. So all I have to do is subtract 50. And I get 130 is equal to my question mark. Now, this is where I want to remind you, my shortcut. These two far inside angles added together is 130. My exterior angle is 130. That is not a coincidence. That's going to happen every time. I'm going to have my two remote angles. My remote angle plus my remote angle equals my exterior angle. So when I get to one harder, like question number 9, where it has variables, and I'm kind of scared of what to do, I remember I don't have that last inside angle, but I do have an exterior angle, and there is that fancy rule with that exterior angle. The exterior is equal to my remote angle, and I'm going to call it R angle for remote, plus my other remote angle. So my two far angles, well, here they are. My exterior is 11x plus 2, and that's equal to one of my remote angles plus my other remote angle. Draw my line down my equal sign and combine my like terms. I have 11x plus 2 is equal to 5x plus 68. Which side has the bigger variable? That's 11, that's 5. I'm going to make this my variable side and this my number side. If this is my variable side, get rid of the 2, it doesn't have a variable. And I'm left with 11x is equal to 5x plus 66. If this is my variable side, it's how I want it to be. If this is my number side, not quite how I want it to be. I don't want 5x. It's not just a plain old number. So I'm going to minus 5x because it's a positive. I'm adding. And I'm going to be left with 6x equals 66. And that's something I can divide by 6 and solve. 66 divided by 6 is 11. Now, remember that's only half your answer. It also asked me to find the measurement of the exterior, and I must have just chopped it off, angle. So the exterior angle is 11x plus 2. Now, if you're like, I don't know what to do, well, let's write 11. X means time, so I'm going to put parentheses. Well, what is x? I'm going to come over here and I'm going to note to self, x is 11. So I'm going to take out the x, replace it with an x, and then continue. After the x comes a plus 2. So I'm going to simplify that. 11 times 11 is 121 plus 2, and I can simplify that to 123. So my exterior angle is 123 degrees. The next question asks us to make the following decision. Are these triangles similar or not? And remember, in order to be similar, I need two congruent angles because two congruent angles makes the third angle congruent. And if all of the angles are congruent, my triangles are similar. So let me just say that again. I need a minimum of two angles to be equal. That's all I'm looking for. The minimum of two angles that are equal. So as I look at my diagram, I can see they both have a right angle and they both have a 20. So I've reached this criteria of two angles that are equal. Remember by default that this remaining angle, x, if I subtract 90 and 20, I'm going to get 70. And so by default, notice that they are also the same. So I'm going to select these triangles are similar because they have two pairs of congruent angles. And if they don't have two pairs, if they only have one pair of congruent angles, that's not enough. It has to be two. So let's go ahead and look at this diagram. Well, I know these are similar because I have 1, 2, 3 pairs of congruent angles, and I only need 2 in order for them to be similar. So because they are similar, I can use proportions to solve for the missing lengths. Remember what that looks like. Two fractions equal to each other. And I'm going to put the big triangle information on top and the small triangle information on bottom. So because my goal is to find x, and that's on my small triangle, I'm going to make sure I put x right first off on the small triangle side. Now what side corresponds to x on the big triangle? What side length is between the 3 arcs and the 1 arc? And as I come to my diagram, here's the 3 arcs, here's the 1 arc, the side length of 8. So I'm going to put 8 on top. I'm matching the small to the big. And then I'm going to go to a different side of my triangle, and it doesn't matter which one. 5 is on my small, so it goes on bottom. And this matching side from 1 to 2 arcs, 1 to 2 arcs is 10. Now if you can notice a pattern, by all means, simplify using that pattern, or we can cross multiply. 8 times 5 is 40. 10 times x is 10x. Divided by 10, that gives me x is equal to 4. Or you can notice the pattern to go from the small to the little, the big to the little. 6 divided by 2 is 3. 10 divided by 2 is 5. 8 divided by 2 is 4. And both ways will work. The dividing rule only works if I can recognize the pattern. The proportion rule, this is the proportion rule, will work every time. So as I look at this example, I'm just going to draw my two triangles out separately. So I've got 9 and 15, and my little one is 7 and h. I don't know what I multiply or divide by to get from 15 to 7, so I can't use my division rule. But because I have two angles that are congruent, so there's my right angle, and these angles are also marked as the same, I can use my proportion. So big to little. Okay, h is my little, so I'm going to make sure h goes on the bottom, so I make sure I have my variable over the matching 9 on the big triangle. And 7 is on the little triangle, and 15 is on the big triangle. So I'm going to cross multiply. 9 times 7 is 63 equals 15h. I'm going to divide by 15. So 63 divided by 15 is 4.2. Yes, I don't think I would have ever guessed that one on my own. So 4.2 feet. And you'll notice on your assignment, it just has a blank spot and then feet. So make sure you fill in that 4.2. All right, 2 more. Use these triangles that are similar. These triangles are similar. Use proportions to solve for the height of the flagpole. So this is, imagine as if I have, these things are casting shadows. So the flag is casting an 85-foot shadow. Here's my 85 feet. My little person is casting a 10-foot shadow, and this boy is 6 feet tall. So I'm going to use indirect measurement and proportions. This is just like the problem you saw in the previous one to solve. So let's set it up. Little triangle, so 2 fractions, okay, big and little. On my little triangle, and first off, let's identify what we're trying to solve for. We're trying to solve for the flagpole pipe height. So x goes on the top for big. Okay, what is the matching corresponding thing on the little triangle? Well, the height of the little boy. So 6 is equal to, what's the length of the shadow on the big triangle? 85. What's the length of the shadow on the little triangle? 10. And I cross multiply. 6 times 85, whoa, that's a big number. 6 times 85 is 510, is equal to 10x, divided by 10 gives me x is equal to 51. So my flagpole is 51 feet tall. Last example. Now this is a kind of a weird one because it's turned. Notice if I were to rotate about this point, like physically drag this shape, D would land on A. So I didn't just slide it to the side. And that's important when I set up my proportion to find those corresponding sides. So these triangles are similar because I have a right angle and a vertical angle. So I have got 2 pairs of congruent angles, which makes them similar. So I can set up a proportion. I'm going to again do big to little. What is it that I'm trying to find? I'm trying to find the distance across the river, and that's on my little triangle. So x goes on the bottom. What is the matching on the other triangle? Now, be careful. Remember, this rotates around. So x lines up with 60. My longest side with my longest side. So 60 over x is equal to, hey, well, 40 is the other length on my little triangle, which matches with the 50. I'm going to cross multiply. 60 times 40 is 2,400. Big number. Is equal to 50x. Cross multiply. I'm going to divide by 50. That's not one I can easily do in my head, so we grab our calculator. 2,400 divided by 50 is a grand total of 48. So this distance right here is 48, and that is the distance across the river. And that's how I'm going to answer all of the questions. If you have any other additional questions, please feel free to reach out, and have a great day.